and not all of it was working very well. But fast forward to today, and now the code is still a mess. Better than it was, but it's tidy enough that I think I can put it up on GitHub, and maybe some other suckers for punishment out there will be interested to give it a try. So this video is going to be explaining some of the steps. Well, I've tried to, let's have a look at the GitHub. I've tried to explain everything on here as well as I can, but some of it's better explained by video, so I will, I think I'll just let you read this. Last time I did a video like this, I went through all of the text on the GitHub page and just basically looked through each step of it, but I'll just let you read this. There's probably not that many people that are going to be interested in trying this anyway, so I'll just let you read that, and I'll go over in sort of a parallel instruction here in the video, just looking at the things, the actual hardware that I've made. One thing I will just point out the very first part. There's 3 sketches involved here. You don't need to use all 3 of them. You only need 2 of them. So obviously you need the follow me tag, which is the thing that you're going to carry around to be the target of the movement and the camera angle. And then follow me controller is going to ride on the quadcopter and talk to clean flight to do the autonomous control. And this other one here, follow me checker, is something that I had around that I found very, very useful over the last year or so doing Arduino projects with the NRF24 modules. And it just sort of prints out all the information that the follow me tag is broadcasting over the radio. So it's just to help it to let you know what's going on. But I would highly recommend, if you're doing any projects with NRF24 modules, just set up something like this. You'll use it a lot in the future, I think. So the point is that only these 2 sketches are necessary to do what we're going to talk about. So the follow me tag is this one here, and I've tried to keep it compact, and so you could sort of strap it onto your shoulder or on top of a helmet, motorbike helmet or a ski helmet or something like that. I'm not sure if carrying it in your pocket would be too great, because there's a GPS in here and you sort of want to let that have a good view of the sky. Originally I had a small battery inside that I ruined, so that's why I'm using this large one outside. This is a 900 milliamp hour 3-cell, just 1 cell, sorry, what I'm talking about. 900 milliamp hour 1-cell battery. It lasts ages running this. So let's have a look inside, and I think I did briefly look at this one time in the past. But what we have in here is an Arduino Pro Mini. I think it's a 3.3 volt one, that one. Yeah, it must be, because there's no voltage regulator in here. So there's 3.3 volt Arduino Pro Mini, and there is an MS5611 barometer. They are connected by an I2C connection. So this being a fairly advanced sort of undertaking, I'm not going to explain a whole lot of details about where all the wires go. I expect that if I say I2C, you should know how that's connected. I have listed it in the sketches, of course, but I'm not going to explain things at that level of detail. So the barometer talks to the Arduino by I2C, and then underneath that I have the antenna there. There's a NRF24 module there, and that's of course using SPI. And I have a couple of capacitors on there. Cost the power for these. Probably not really necessary to have 2, but it's been working really well with those 2. I think one's a 10 microfarad and one's a 0.1 microfarad, and that works really great. I just have a little switch here, turn it off and on. I just use the number 1 switch of that to do that. And then down here I have a U-Box, or U-Box compatible, I think. I'm not sure if it's an official one. And this is a Neo 6 series, so you don't need to have the 7 or anything newer. Like a couple of my other sketches that I've uploaded were made for the 7 series, and people have been asking me questions about why it doesn't work with the Neo 6. But this one will work with the Neo 6, so we shouldn't have any problems like that. And this is a serial connection, so we've just got the RX and TX there, the power of course. And this GPS module I have runs quite well off 3.3 volts, so I've been able to just connect this directly to my Arduino's VCC for power. And you'll notice that it's going on to the RX and TX pins of the Arduino, so it's using hardware serial. And that's necessary to get the data in from the GPS fast enough. If you use a software serial, the data just comes in very intermittently. It's not very reliable. So one of the downpoints with connecting to the RX and TX pins like that is that when you power it up, the GPS is going to be talking to the Arduino, sending it information. So if you want to connect your computer, or you want to upload a sketch onto your Arduino again, it won't work. Most likely it won't work. So I found that whenever I want to upload the sketch onto the Arduino, I have to disconnect the RX pin, I think. One of them anyway. I think it's RX pin you need to disconnect, just temporarily to upload the sketch. So not too much more to say about this. The barometer ideally would be better shielded from the wind and the light than what I have done here. I did have this little piece of fluffy stuff that I put over it when I closed the lid just to shield it a bit better from wind. But I have noticed that it does sense when it is in strong sunlight or weak sunlight or overcast, under the clouds. So that's why I have that black marker pen scribbled on there to try and mitigate that problem. But even so, it still does manage to sense when the sunlight is, when it's brighter. So ideally the barometer would be in a pitch black box. But it doesn't seem to be too much of a problem. So that's the tag. And the tag is continuously broadcasting the latitude and longitude and horizontal velocity. So that's velocity north and velocity east. and the altitude coming from the barometer, and what else? Yeah, that's all. So it's just continuously broadcasting that over and over and over as fast as it can, and that's all it does. And like I say, with the 900 millionth output 1S battery like that, it lasts for ages. So over here I have the checker, and this is the part that's not really necessary, but I made this thing ages ago and I've been using it for a lot of other NRF24 projects, and it's been really, really handy to have this around just to quickly throw a different sketch on and check that the data that I'm expecting to be sent is actually being sent before I try and do something more complicated on the receiving end with the actual, follow me sketch. So this one has, again, a Pro Mini NRF24 module, and you're going to need some kind of a screen to see what the data is, and I'm using one of these I2C, the little OLED screens. These screens are really handy. And even though this is a, I got a bit lucky with this, I think. I didn't realize for a while how lucky I got, but this is a 5 volt Arduino, and this NRF module here is supposed to be powered by no more than 3.3 volts. It's actually, if you look at the spec sheet, it says that ideally it should be about 3 volts if your signal inputs, like your SPI signal wires, are giving 5 volt signals. But what I've done here is I'm powering it from a 1S LiPo that's about storage charge, so that's about 3.7 volts. And just luckily, that all seems to work. So it's not the ideal voltage for either of these things, but still hasn't given me any problems in about a year and a half. Right, so when I turn this on, you'll see that every few seconds it switches between 2 different sets of information. So first thing at the top is how many drops. This used to be a number counting up to say how many packets it had missed, but it wasn't really important to know how many, so I just left it at 1, which means that every time it's tried to receive something, it failed. And the DPS below that is packets per second, and it's obviously 0 because our transmitter is not on. And then we have velocity north, velocity east, and lat long and altitude. So they're all 0 at the moment because the tag is not on. So let me just turn the tag on and we'll see how these change. I'm just going to turn this little switch, a bit fiddly, and then quickly pick this up again. And then we'll see packets per second goes up to around about 50 briefly, and then it'll drop down to 0. And then so this lets you know that the altitude readings is coming in correctly. Interestingly, we get, oh, this is 50 packets per second. See, I found that when I place this, watch how the packets per second goes down when I place the tag on the desk. So it goes down to about 30. Wow, 20 something there. I think it's the reason is that the antenna is flat along the desk. If I lift it up just a little bit above the desk, so now it's about a centimetre above the surface of the desk, now it goes back up to 50 packets per second. Interesting, eh? Anyway, that's kind of beside the point. But you should be seeing around about 50 packets per second. I think it's the most I've ever seen, maybe 52, 53 or something like that occasionally. Right, so at the moment there's no lat long coming in, and there's no velocity north and east, because these are the numbers that come from the GPS module, and I'm inside at the moment, so probably not going to be able to pick up any signal from where I'm sitting at the moment. Incidentally, the M8N module picks up signal quite well from where I'm sitting right now, but this is not such a sensitive GPS module I have in here. So let me go and I'll put this outside, and then we'll see how that affects the numbers coming into here for my velocity and lat long. Okay, so I've just put the tag out on the veranda. Still nothing coming in yet. The signal has to go through quite a few walls now to get here, so we're only getting 10 or 11 packets per second, but you should have some decent GPS reception now. Okay, there we go. So that is